Hello everyone. Let's start a new questions about derive relationship between duty and delta for a given base period. Also briefly discuss factors affecting duties. Question asked in 2022 for 7 marks in GT. So this is the most important questions here. There are some numericals also about duty and delta and with the relationship you can find out what is duty and what are the deltas. So you have to go through these numericals. In the context of irrigation engineering, duty and delta are terms used to describe the relationship between volume and water delivered to the field and the change in water level in the field over a specific base period. The relationship between duty and delta can be expressed as follows. Relationship between duty and delta. Let's D is a duty in hectare per cumex. Delta is a total depth of water supplied. The B is a base period in days. If we take a field of a area d hectare, water supplied to the field corresponding to the water depth delta meters will be is equal to delta into duty, which is in hectometers, is equal to d into delta into duty into 10 raised to 4 cubic meters. Again, for the same field of duty d hectares or duty in hectares, 1 cumex of water is required to follow during the entire base period. Hence, water supply to the field is a 1 into B into 24 into 60 into 60. This is for the hour or for entire day, 24 hours, 60 minutes and 60 uh, seconds. Meter cube. So equating the both equations, equation 3 and equation 4, d into delta into 10 raised to 4 into b into 24 into 60 into 60. So delta is equal to b. So we will get delta is equal to 8.64 b into b divided by d, which is in meters. 8.64 b. B is a base period and divided by duty. Okay, so this is a relationship. Now what are the factors affecting the duty? First is a crop water requirement. Different crop have various water requirements and the duty will depend on the types of crop being irrigated. Like there is a sugarcane, there is a rice, there is a wheat. Crops will be higher water requirement, will be have higher duties. So like a sugarcane requires much water, so it has a higher duties. Soil types. The soil textures and permeability affect how water moves within the soil profiles. Sandy soil typically requires a more frequent irrigations and may have higher duties compared to loamy or clay soils. Next is the climate and evapotranspirations. The local climate, including temperature and humidity, influence the rate of evapotranspiration. Water loss through transpirations and soil evaporations. Areas with a higher evapotranspiration rates may require higher duties to meet a crop water demands. Irrigation methods. The choice of irrigation method, whether the surface irrigation, whether the sprinkler irrigation or the drip irrigation, can be impact duty. Efficient irrigation methods can often achieve higher duties. Water source availabilities. The availability and reliability of the water source, such as a river, reservoir, or groundwater, can affect the duty. A consistent and simple water supply can support higher duty. So there is a ample, not ample, simple, sample, simple. Okay. Infrastructure and convenience losses. The efficiency of the irrigation infrastructures, including canal, pipes, pumps, affects the delivery of water to the field. Higher convenience losses may necessitate higher duties to compensate for losses during the transportation. Next is the topography. The field slopes and the topography can influence the distribution and management of irrigation water. Fields with various slopes may require adjustments in the duties to ensure uniform water applications. Regulation and water rights. Local regulations and water rights may be impose restrictions on water use which influence the duty considerations. In summary, the duty in irrigation is a crucial parameter that represents the relationship between the volume of water delivered and the change in water level in a field over a specific base period. It depends on a varieties of factors including crop type, soil characteristics, climate, irrigation methods, and local conditions, all of the which must be considered when the designing and managing irrigation systems for optimal water use efficiency. Thank you.